How many of you watched the homework video? Is that a useful thing? Is it better than just having it printed out? It's more work, but if y'all find it useful, you can solve it. Yeah. But I'll do my best. It won't happen every time, but I'll try. Okay. So these special triangles you would have encountered way back in geometry, so long ago. It seems like a whole nother lifetime. Life was different then. You were young and carefree. You probably didn't have a job yet. You probably couldn't drive. Life was so much simpler. So these are triangles that you'll run into, and you actually see them on like formula charts for SAT and ACT tests like that. And let's start off with the formula chart version. So maybe you remember these, maybe you don't. Usually they take one side and call it X. Okay, let's call this side X. Okay, well then how long is this side over here going to be? It could be the radius, yeah. But specifically, it has a special relationship to this side. They always have the same ratio. Yeah. This side's always going to be twice as big. So if this side was, like this short leg over here was 7, then this hypotenuse over here would be 14. Twice as big, right? 2 times x. What about this side over here? It involves one of these things. Hey, you know what? We could figure it out really quickly. How can we figure out the third side of this triangle? So something squared, let's just call it b squared, plus this squared equals that squared. Pythagorean theorem. Okay, so what would 2x times 2x be? 4x squared. Okay, now all I have to do is solve for this side that I called b. So what would I do first? What should I do next? Yeah, subtract the x squared. And I can subtract that from this because they're like terms. So there they cancel. So b squared is, so what would that be then? 3x squared. And then the last thing I need to do to get b by itself, take the square root. So the square root of b squared is b. That's just what I decided to call this side for no good reason. And the square root of 3x squared. Now, does 3 have a nice, pretty square root? No, so I'm going to leave that underneath the square root. I can't take the square root of 3. Can I take the square root of x squared? What is it? X. So how long is this side over here? Yeah, the square root of 3 times x. And it's usually actually written the other way, although it's the same thing. X times the square root of 3, like so. So there's one of those special right triangles. This is the formula chart version. So that way, if you know how long the short side is, you can just double it to get the hypotenuse. Or you can just slap a square root of 3 on the end to get this other longer leg. Now what if I started off knowing that the hypotenuse was like 20? So this time it doesn't explicitly tell me x, but I could still figure out how long the short leg was, right? So what would I do? Yeah, I would divide by 2 instead of multiplying by 2, right? The inverse. I'm switching my input and my output. Okay, so I could have like 20, and then that would be 10, and then this would be 10 squared. Okay. So let's look at this other triangle. So this other triangle, let's say I just gave you this one side, okay? Now I'm going to claim that you should be able to find all 3 other sides from just this one value. Usually we need 2 if we're going to do the Pythagorean theorem, but this is a special type of triangle. Besides being 45, 45, 90, you remember what it means when these two angles are congruent? What type of triangle it is? Isosceles. Which means that these two sides would also be congruent. So if this side is x, whatever that is, if it's 4, then this side is also going to be 4. So we've got x there and x there. Now what about that hypotenuse? Well, maybe you remember, maybe you don't. Either way, you can really quickly figure it out. How would you figure it out? Yeah, Pythagorean theorem. How do you find the third side of a right triangle? Use the Pythagorean theorem. So how would I set this up if I'm going to solve for that third side? We'll call it C, but just temporarily. So I need leg squared plus leg squared, right? So that would be x squared plus x squared equals c squared. And now we've just got to figure out what c would be. So we've got to solve for c. X squared plus x squared. Can I simplify that? Can I combine those? Yeah, 2 x squareds. Add the coefficients, 1 and 1. And I'm almost done. How would I get c by itself? Yeah, take a square root. What's the square root of 2? Well, just the square root of 2. It doesn't have a nice square root. What's the square root of x squared? X. And what's the square root of c squared? So how long is this side? And it's usually written the other way around. X times the square root of 2. Square root of 2 times x. So in other words, if I told you that this side over here, this leg, was 12, and if you had this formula chart on, say, the SAT or something, then you should be able to tell me how long all of the other sides are. So if this side is 12, how long would this side be? 12, that's the easy one. And then this side? 12 times the square root of 2. Okay. So these are some special right triangles that you will have seen before, and you will see again in this class. Again, like most of the stuff we're talking about right now, you're going to see this every single day for the next 2 months. So you're going to get really familiar with these two triangles. But instead of having these x's as variables, what we're going to have are some specifically sized right triangles. So this 45, 45, 90 could be any size. It could be this big, or I could make it twice as big, or 10 times as big by stretching it out. We're always going to want one particularly sized special right triangle. So I'm going to draw these again, and this time we're going to look for some specific values. Okay. For reasons that I'll make clear later, we're going to draw these triangles inside circles. I think I already mentioned that. But specifically, the circle is always going to have the same radius. And on the triangle, which side is the radius of that circle? Yeah, it's the hypotenuse. And we're always going to give the circle a radius of 1. Why? Well, it's going to make some things simpler a little bit later. That's all I'll say about it now. It's called a unit circle. It has a radius of 1 unit. Okay. So that means for the particular triangles that we're using, we're always going to want the hypotenuse of the triangle, which is the radius of the circle, to be 1. Okay? Just believe me if you don't like that. Why is it 1? Well, it's always going to be the same circle. It's always going to be 1. You'll see why later. So, what I want you to try and do is to tell me all of the other sides of each of these triangles. So I'll give you a second to do that. You might want to put back to the other page. Look at those two little formula chart triangles. See if you can find the other two sides. Let's write these as, there are some square roots involved. Just leave the square root in there. Give them as exact values instead of decimals. Shouldn't have to do a whole lot of calculation here. Think about what I'm doing. All right. So I've got this side right here, and a lot of us got this part. So to go from the hypotenuse of a 30, 60, 90 triangle to what we'll call the shorter of the two legs, we'll call this the short leg, and this the long leg. So what would I do? Instead of multiplying by 2, I do, so I would divide by 2. So what's 1 divided by 2? 0.5 or 1/2. Same thing. Okay. Now to get from this shorter leg to the longer leg, to get from here to here, what do I need to do? Take this value and do what to it? Multiply by the square root of 3. So let's do that here. I'm going to take this, not the hypotenuse, but the short leg value, and multiply it by the square root of 3. And when I do that off to the side here, times 1/2, where would that square root of 3 get multiplied? The top, the bottom, both, neither? Yeah, it gets multiplied on the top. So that's the square root of 3 over 2. That's the most compact way to write that. And if you wrote it as 0.5 times the square root of 3, well, that's technically true. It's going to benefit us to always write these as fractions. So go ahead and rewrite it as a fraction. So the square root of 3 divided by 2. That would be the best way to write it. The most useful way. Okay. Now let's look at this other triangle. It's 45, 45, 90. So to figure out its sides, I'm going to go back to this template right here. Now, in this template, it's assumed that we're given the leg length, and we want to find the hypotenuse. To find the hypotenuse, we have to multiply the leg by the square root of 2. But that's not what we have here. We have the length of the hypotenuse. So what would we do to work backwards and get the leg length? You would divide by the square root of 2. That's the inverse of multiplying by the square root of 2. Dividing by the square root of 2. So that's what we'll do here. Does that make sense? Multiply the square root of 2 to go this way, divide by the square root of 2 to go that way. It's an inverse. Inverse operations. So let's do that here. So to get from 1 to this other side, I need to divide by the square root of 2. Now, off to the side here, what's 1 divided by the square root of 2? Well, can I leave a number looking like that? Can I leave this with a fraction and a square root on the bottom? No? Why? What's wrong with it? Seems fine to me. So y'all have heard not to write a fraction with a square root on the bottom, right? Did anyone ever tell you why? No, that's fine. You got that in your calculator, right? It worked out just fine. So it turns out, there's not really a great reason. But the reason we're going to do it is because it's going to help us see an important pattern. Okay? So, to write this without a square root on the bottom, to fit mathematical convention, can anybody tell me what we would multiply by? How we would fix that fraction? Which same thing? So multiply by another 1 over square root of 2? Almost. But that would leave us multiplying by a different thing on the top and the bottom, which would change the value of the fraction. We have to multiply by the same thing on the top and the bottom. Yeah. We need to multiply by the square root of 2 on the top and the bottom. It's called rationalizing a fraction. So what's the square root of 2 times 1? Hey, what's the square root of 2 times 1? Yeah, it's the square root of 2. And what's the square root of 2 times the square root of 2? It's a regular 2. The square root of 2 squared. So then how long would this side be? Just go to the AP office. All right. So this other side right here would be the square root of 2 over 2. Okay. So these two triangles right here are basically going to give us the answer to pretty much every question that I ask for at least 2 weeks. And then after that, we're going to use the answers to those questions to try and do more stuff with these trig ratios. Now, before we go on, y'all are just like dragging. We're dragging. This is one of the least exciting days of pre-calc. I know that. It's kind of a boring lesson, but it's a really important one. So we need to get a little bit more energy. Okay? So here's what we're going to do. I've got this ping pong ball, but it's not really a ping pong ball. Okay. It's actually a circle. So, to try and share a little bit of energy here, what I want to do is turn our whole class into a circle. Did you know that you're electrically conductive? That's why light and water are great. So look out for that. Bad experience? Nope. Nope. All right. So you think we can do this? Okay, everybody stand up. Let's make a little circle. Okay. I touch both sides, the circuit only goes through these. That's not very exciting. The circuit is one. So what you need to do, I won't make you hold hands, but you will have to touch at least some skin to skin on the person next to you. Now, before we do that, you can wait a second. So I'm going to have Turner touch the other side of this. And so me and Turner aren't touching at all. If we did, give me a high five. We make a circle. Right? Right? So, with them touching that,
It actually is.
I want you to do, so on 3, I want everybody to either high five or something with the person next to you, okay? And we're going to make a circle, right? It needs to be like a slow-mo high five, okay? So 1, 2, 3. Yeah. All right. You feel the energy? Wow. I feel so refreshed now. Okay. That was awesome. Yep. Yep. All right. Really makes the hair stand up on your head. Okay.
I was literally looking at it. I was like, is it gonna go like this?
What was it? Was it the Matrix where they were using the spoiler alert? Battery. All right.
What?
So I have some questions for you. Okay, so I'm claiming that these two triangles right here can answer a lot of important questions, and they can. They might not seem like important questions to you yet, but you're the one who took freak out. Okay. For example, let's say I wanted to know what the sine of 30 degrees was. Okay. So what I can do, I can find a 30-degree angle that's part of a right triangle. Ooh, I found one. It's right here. So here's a 30-degree angle. And to figure out what the sine of 30 is, I just pick the right two sides and I make a fraction. So sine is what? Over what? That's so, right? Yeah. Opposite over hypotenuse. So which side is opposite from the 30-degree mark? Yeah, the 1/2. Over, and which side is, yes, so much excitement. Okay. And now all I have to do is simplify that, and here's the reason why, or at least a reason why we choose 1 to be the hypotenuse. Because when you calculate sine and cosine, you end up dividing by 1, and that's really easy. What's 1/2 divided by 1? 1/2. Now, try this in your calculator. Type in sine of 30, preferably in degree mode. What do you get? 25. Okay, so, and that's great. So let's try this with another one. Okay, so you might think, well, I should have just typed that in my calculator instead of making a fraction. That would be so much easier. Okay, sure. Let's find the, let's say the cotangent of 60 degrees. Hey, what's the cotangent of 60 degrees? Now, you might not remember the cotangent off the top of your head, but it's the reciprocal of one of those other ratios. Do you remember which one it's the reciprocal of? Yeah, it's the reciprocal of tangent. So tangent is opposite over adjacent. That's what TOA stands for. So then cotangent would be what over what? Yeah. Adjacent over opposite. Okay, so find the 60-degree angle. And which side is adjacent to 60? 1/2 over, and which side is opposite from 60? Now let's try and simplify this. Here's a problem we've run into before. We're dividing by a fraction. What's an easier way to divide by a fraction? Tricky shortcut. What? Yeah. Multiply by the reciprocal. Flip the bottom. So instead of dividing by the square root of 3 over 2, I'm going to multiply by 2 over the square root of 3. And you might notice here, the 2's are going to cancel. 2 on top, 2 on bottom, gone. So that's 1 over the square root of 3, which would be a great answer, except it's got a square root on the bottom. How do I fix that? Okay. So what is the cotangent of 60? Written in a pretty manner. It's the square root of 3, and then on the bottom, square root of 3 times square root of 3 is regular 3. So it's the square root of 3 over 3. So there's something your calculator won't tell you. It'll tell you it's like 0.5 something. But we want the exact answer here, because these exact answers are going to help us find important patterns. Okay, let's try one more. What about the, let's see, secant of 45 degrees? What's the secant of 45 degrees? Do you remember which ratio secant is the reciprocal of? Good. Remember, there's always a c in one of your pairs. So secant starts with an s. Its reciprocal is going to have to start with a c. It's cosine. It's not sine. So cosine, what I meant to write was cosine is the adjacent over the hypotenuse, which means secant is what over what? Hypotenuse over adjacent. Flip it upside down. So how long is the hypotenuse? Yeah. So pick a 45-degree angle. It doesn't matter. The hypotenuse is always going to be 1. And what is the adjacent side? Yeah. And again, it doesn't matter which 45-degree angle you pick. The adjacent side is the same. So 1 over the square root of 2 over 2. And instead of dividing by that fraction, I'm going to multiply by its reciprocal. And I'm multiplying by 1, so really, there's almost no point in me writing that. It's 1 times, so I'm going to take the reciprocal of the bottom. 2 over the square root of 2. Okay, so multiplying by 1, pointless. So I've got 2 over the square root of 2. But I've got a square root on the bottom. I need to fix that. So what am I going to multiply by? Square root of 2 on the top and the bottom. And I get 2 times the square root of 2, whatever that is. And then what do I get on the bottom? Just 2. And one more thing I can do. Cancel. And I just get this nice, pretty answer. The square root of 2. That is nice. Or about 1.4. Okay. So, these things, because we're going to practice them so much, eventually, you'll see this, you'll see a 1 over that, and you'll be like, oh yeah, that's the square root of 2. This over that, oh yeah, that's the square root of 3. So you won't have to work this out every single time. Because really, here we end up just using the same numbers over and over again. How many different numbers are there for these sides, these side lengths? See, there's 1, 2, 3 different ones right there. We already used 1, so 4. It's just the same 4 numbers over and over again, right? And you're not even going to make fractions out of some of them, like these 2. They're in different triangles. You don't have to worry about that fraction, or those 2. You don't have to make that fraction either. So there's a pretty small number of answers that you can get here. So for that reason, you're not going to have to do this simplification every single time. You'll just be able to do it in your head. And if you practice, which you're going to have to, you'll be able to do these in about 10 seconds. Let's see, sine of 30. So I would draw the sine of 30, and I think, okay, 1/2 over 1 is 1/2. That's how easy it's going to be for you to do this. But to get to that point, we need to practice things. So first, I'm just going to have you answer a couple of these questions by yourself. So answer these, and then we'll bring this back to circles. All right, let's talk about these. It's okay if you're not quite done. So a tangent of 45 degrees. Look at your triangles, find a 45-degree angle. Tangent is opposite over adjacent. So square root of 2 over 2 divided by the square root of 2 over 2. And anything divided by itself is 1. So that simplification works out pretty easily. Okay, what about cosine of 30? Well, find a 30-degree angle. There's one. What is its cosine? Is adjacent over opposite. Sorry, no, it's not. Over hypotenuse. Ka. So adjacent would be square root of 3 over 2. I'll try to write legibly. And hypotenuse would be 1. So anything divided by 1, yeah. So it's just square root of 3 over 2. A lot of times the simplification is going to be really easy like that. This is another reason that we choose 1 to be the hypotenuse. Cosecant of 45. Cosecant starts with the C. Its reciprocal doesn't. What is its reciprocal? Yeah, sine, which is opposite over hypotenuse. So this is going to be hypotenuse over opposite. So find a 45-degree angle. Pick your favorite one. I like the one on the left. You can You can choose the one at the top if you want to. You're going to end up with the same answer. So it's hypotenuse, which is 1, over the opposite side, which is the square root of 2 over 2. Now, I feel like we've done this simplification already in the recent past, haven't we? So that's the same thing as the secant of 45. So through the same set of steps, we would end up with the square root of 2. And so you'll see these same basic fractions get used over and over again. There really aren't very many answers that you're going to come up with. So eventually you'll just recognize these. Oh, that over that? Okay, that's the square root. Right. I think we're going to save the circle for next time, because otherwise we'll make half of a circle. Oh no. Yeah. Let's save the circle for next time. So instead, what I'll have you do is a little bit more practice on these problems. And the homework will be the same thing. And again, just knowing how to do the problems isn't enough. You need to be good at it. Because these are just going to be small background steps that happen as you're solving more complicated problems. So you need to be able to solve these correctly, but you also need to be able to do them fast without reaching for your calculator, without doing a bunch of scratch work off to the side. So your goal here eventually should be, if you have those triangles written in front of you, which you will for now, to answer these questions in, probably for now, maybe like 15, 20, 30 seconds, something like that. Okay, so practice these. So I'll ask you questions like this. These are really easy problems to make up. I just have to pick one of those special angles, and then pick one of the 6 trig ratios. So I'll make some more up. Okay, so let's practice these a little bit more. We're going to have a bunch of quizzes pretty much every day. And pretty much all of them are going to be closed notes. So I'll ask you some questions like this, and I'll want you to be able to answer them. And it'll be timed again. Okay? So let's practice these right now. We want to get really good at it.